Electromagnetic radiation.
All right, you all just lost 10 points on the quiz.
A form of energy that travels through space with wave-like behavior.
That's the answer. Okay, I'm not asking the abbreviation. All right, when I wrote EMR above it, I gave you that so that you could write the abbreviation so you didn't have to write out the word electromagnetic radiation. Okay, that's just the abbreviation. I want you to tell me what EMR is. I mean, you can tell me that EMR is. Dude, I don't ever want the abbreviation, okay? For as long as you're in my class, from now until January, I am never, ever asking the abbreviation, okay? That's like me asking you for the symbol of sodium. Why would I ask you for the symbol for sodium? I have 3 periodic tables hanging in the room if you count that itty bitty one at the back, and I gave you one. You're going to have one on the exam. I never want an abbreviation. Ever. Okay? Ever, ever. I always want you to tell me what it is or what it means. Okay? Always. Is that clear enough? Okay. So if I say, what is something, and I gave you some letters, I'm never asking what the shorthand letters stand for. I want you to define it. Tell me what it means. So it means what again? For those people who wrote the abbreviation? There we go. Okay? And wave-like behavior. The form of energy. It travels through space in wave-like behavior. Okay? So, if I had given a quiz today, those would have been the first 2 questions. Okay? If you couldn't have answered those, you'd have lost 20 points.
So is it safe to say that a quiz is all that plus like 2 more working out?
Oh no, I'll pick something different for Monday.
Wait, what?
I mean, there might be a few of those, but I'll pick something different out of mine. Trust you for Monday. Oh, I have a variation. Oh yeah, sorry, we're not Friday. Dang. I was thinking it was Friday. No, tomorrow. I have to pick something different for tomorrow. Yes.
Okay, so like, if you don't put it in those exact terms.
Oh yes, as long as it means the same thing, I'll give you credit.
Are you if I leave out the word energy? Like,
Oh no, you have to have energy.
energy.
Yeah, electromagnetic radiation is energy, so you have to have that. But if it doesn't, say wave-like behaviors, it travels through space, as long as it, means the same thing and says the same kind of thing, then I'll give you credit. Okay, it doesn't have to have the exact same words as long as it means the same thing. All right, so 3 examples of EMR. You could add lots of different answers here. UV, X-ray, gamma, microwaves, radio rays, visible light.
So is gamma rays?
You can write gamma or gamma rays. Either one is fine. You said who? Did he say Israelite? Okay. Number 4. What's wavelength?
The distance between 2 corresponding points.
All right. The distance between 2 corresponding points on adjacent waves. What's the unit for it?
Nanometers or meters?
Nanometers or meters. And what's the symbol? Lambda. Or you could have drawn the upside down Y. I would have taken that also. All right. What's the frequency? Yes. Number of waves or the number of times a wave passes a given point in a given time. Its unit would be a hertz, and its symbol for frequency is U. All right. You could say nu, or you could have written the italicized V, or just V, because you probably can't draw it italicized any better than I can. All right, how are frequency and wavelength related?
They're inversely proportional.
They're inversely proportional.
So if we wrote like if the longer the wavelength, shorter.
I did both because I didn't know what she was looking for.
I'm looking for the math word. Inversely proportional.
That works.
So we don't.
You don't have to.
Inversely proportional.
It's fine. I'm assuming you know what that means now. So if you wrote inversely proportional, I'm assuming y'all know what that means. All right? I'm going to give you the benefit of the doubt. And number 7. What color did you come up with?
Red.
Red? Yellow.
Oh, wait, no.
I got
I think
red.
red's too high.
I got
yellow.
Okay.
Oh no, that's the melon.
I didn't get that. How do you get something eight?
If you use it in other places.
Even if you divide it.
I got yellow.
When you divide the 3, that's your actual answer. That's your
But well, we passed what?
Yeah, I would say
What is this? I forgot.
All right, so 5.85. All right. All right, I just used the shortcut. 585, I put the decimal at 5.85. So when I look at these, 5.85, where's it going to fall? Is it after 5.9?
No.
So orange is out. Is it before 5.7? Green is out. 5.85 falls between 5.7 and 5.9. That's why it's yellow. Okay, just checking. All right, minimize that in case I want that later. All right, so if we go back to calculating, because we need to be able to calculate the last one. All right, we need to take the 585 nanometers. All right, nanometers to meters, 1 times 10 to the what? 9. We get 5.85 times 10 to the -7th meters. That is our wavelength, right? So now we're going to use our C equals lambda nu. We know the speed of light is 3 times 10 to the 8th. Wavelength we just found is 5.85 times 10 to the -7th times V. We're going to divide by 5.85 times 10 to the -7th here, which will leave us our frequency. And we're going to divide here by 5.85 times 10 to the -7th. When we do that, what do we get for our frequency? You got what? 5.13 times 10 to the 14th, and you got hertz for a unit, correct? Questions?
You just put 3, like, you put the 23. Does it matter, like, if we don't use that, we're gonna take off? Because I put it because I thought there was a reason, like, being there.
She's thinking for speed of light.
Oh,
I should probably explain these things better, but that's what I was talking about.
it doesn't matter.
Okay. Because I thought there was, like, I was like, if it's there and it's not
Doesn't
there,
matter.
it has to be there.
Yeah, why is it?
Isn't it just?
I still thought it was.
It's just there for significant digits.
Don't use.
I was just lazy when I wrote it up there.
Okay.
I just left it off because it doesn't really matter when I divide, and I was just lazy, so I didn't write it. I don't have a better answer. Anybody else have a question on the opening? All right, so the lab papers, questions on that I handed back first.
Yeah.
All right, so that was opening number what? 2. All right, so openings are done. Lab papers first. And I don't want to work on these forever. By 9 o'clock, we got to be done moving on to content. All right, so lab papers, questions.
What are we supposed to write into this purpose?
You should have told me the purpose was basically to find the empirical formula. Maybe you could have said the molecular formula and from lab data would have basically been it. And most of you did not do that right in calculation section. There were, I think, maybe 3 people who did calculations 1 and 2 correctly.
I said I got the percent composition.
Yeah, that's why most people did it wrong. Here's Lolly's papers. And those are her Reno's. Oh, here's one more of yours, ABL. Here. Right, give me your right here. If I didn't get it right, I can give you your name. No need to tax my tired brain. All right, so I'm going to use Diamond's data in her data table. Where did I put the pen? There it is. All right, so in her data table, for her mass of mg, she and her partner had 1.14 grams. For her mass of oxygen, they had 0.72 grams. And for their mass of magnesium oxide, I'll just write that above because it's above it on the data table. Our mass of magnesium oxide, they have 1.86 grams. Okay? So your data table has different numbers, but those are the last three numbers in your data table. So MgO, mass of magnesium, and mass of oxygen. Are you okay on what I got out of the data table? Yep, leave it on my desk. All right, so in number one, it said calculate the percent of, was it magnesium?
Yeah.
Okay, so when it said use your lab data, and this is where everybody went wrong because y'all just calculated the percent of magnesium using the data off the periodic table. You were supposed to use this. All right, so you're going to take the mass of magnesium, which is 1.14, over the mass of your magnesium oxide, which is 1.86, and multiply it by 100. So you take your mass of magnesium, whatever it is in your data table, and put it over the mass of your magnesium oxide, whatever it is.
Wait a minute, how is that the abundance on Earth?
Huh?
You said the percent of it on Earth. Like that's what we got percent of that. But how is that the percent? When we learned it, you said it's the mass times the.
You're talking about the ice. You're talking about an isotope, and you're thinking about calculating average mass using an isotope. When you're thinking about that, no, we're talking about an empirical formula. You're confusing that with an average mass using an isotope, calculating the different things with an isotope. And then for oxygen, you just take the 0.72, which is your mass of oxygen, over the 1.86, and then times 100 again. But you're thinking about when we calculated the mass for the periodic table for an isotope, when you have like 3 or 4 different isotopes, and then calculating the mass of the isotope.
So you don't have to find the percent of the entire formula? Like that's what I did.
No. No. Nope. That's all you're doing is taking the mass of whatever the element was over the mass of the compound. And times 100. That's all you have to do in those two. And then most of you did 3, 4, and 5 right. But 1 and 2 is where most of you did it wrong. Anyone else have a question? The observations for most of you were just sort of pitiful. Y'all skipped over what the magnesium looked like, and most of you didn't describe what it looked like while it was burning. You told me a lot about the ash, and y'all were very specific about it smelled bad with the cumulative smell, but y'all just glossed over what the observation looked like and gave me 2 or 3 sentences. All right? Apparently a lot of y'all have cats. Anyone else have a question on the lab? All right, don't lose these because we're going to do another lab. And you got to write a lab report with it because we're going to do it. Right now the schedule has not changed, so we've got a half day Wednesday.
No school Thursday?
And right now we don't. It's Parent Conference Day. Feel free to take yours. Come visit me. I'll be here. I'm assuming 12 to 7, just chilling, waiting on people to come talk to me.
Are you gonna say bad things about me?
Huh? I know. Some people do it.
Are you gonna say bad things about me?
Maybe.
Terrible.
Terrible place. Yeah.
How many more lab visits do you have for the rest of the class?
2, possibly 3, but 2. Because we do the chalk lab and then we'll do 1 more lab. Sometimes I do the salt lab, sometimes I do the specific heat lab. It just depends on which one I decide to do. But we will do at least 2. I shoot for at least 3, so you have at least that experience going into other lab classes. But the salt lab, sometimes I do, and sometimes I do specific heat. Salt typically tends to be lower, specific heat tends to be higher, so it just depends on which one I decide to do. Salt is a stoichiometry lab that I usually do with the gas laws. Specific heat we'll do closer to Christmas, so just depends. But the chalk lab we're going to do next week because it's a nice lab to do on a short day, and we'll only have about an hour next Wednesday. Yeah. You can choose. You guys have your 3. You've done Earth. You've done biology, and this is your 3rd. So theoretically, you don't have to take any. Now, for those of you who are sophomores, I would recommend taking the third one. I wouldn't stop. I mean, I would choose to take another one. You've got anatomy, you have forensics, and Ms. Wicker starting, which sounds really cool. I think it's a great one. You've got, you can take AP ecology or AP environmental. All right, moving on. We can talk about that another day. Yep. All right. Data, Molly. All right. So let's look at the stoichiometry test first. All right. So I need to send Lolly out. She didn't do the stoichiometry test. And Lois, you didn't take the stoichiometry test. You plan to take it this afternoon? If you did not take it this afternoon, don't matter. Lolly, you gonna take it this afternoon? You can't, then you might as well stay because you only have this afternoon to take it. So if you don't take it today, so it's 0. Okay. I mean, them's your options. Take it today or keep it 0. Anything's better than 0.
Trust me, it is.
I need to.
All right, so if we look at the stoichiometry test on the 1 through 15, what questions do you have? Look at the stoichiometry, not the benchmark.
Number.
Anything on 1 through 15?
No, I just messed up. That was me.
Yes.
That was me.
Number 5, Carol, we take this. I was mad. All right, number 5 says, oh yeah, this was a flipping mess. Phosphoric acid. Half of y'all still don't know phosphoric acid. It's not going away, people. All right, magnesium hydroxide. Hydroxide is OH. I don't know why y'all can't find that one on the oxidation sheet. It's there. All right, +2 and -1, bring your 2 down. Phosphoric acid is just like any other compound. H is +1. Phosphate is what oxidation number? That 3 came from up there, but you can look up phosphate if you don't know that. What kind of reaction is this? So double displace. Switch the 2. H and Mg are flipping. So H is now with OH, and Mg is now with who? So +1, -1, they cancel. +2, -3, bring your 3 down, bring your 2 down. All right, so from there, we have 3 H's. We have, let's do the Mg's first. 3, so put a 3 there. That gave me 6 OH's. So 6 OH's, 6 H's. I only have 3, put a 2 there, 2 phosphates, 2 phosphates. In the question, I have 15.89 grams of magnesium hydroxide. So grams of magnesium hydroxide, and I need to find moles of something. Moles of phosphoric acid. So I need moles of this. Okay, so I'm going to moles of what? Can I change compounds there? Nope. So I'm putting magnesium hydroxide on top. Moles of magnesium hydroxide on the bottom. And then I can go to moles of phosphoric acid on the top. And that's what they asked me for. So using my coefficients, that has a 2. This has a 3. And that's all I get with coefficients. This always has a 1. And I need to add that up. Magnesium has a 1. Hydroxide, split it apart. There's 2 and 2. Times 24.3 times 16 times 1. 32, 2, 24.3, 0.3, 4, 8, 5, 58.3. So when I multiply and divide, what did Caroline get? 0.58. 0.1826. You need 4 significant digits there, and then moles behind it. Questions? That was probably the most missed question on the test. That was a disaster. I took off 8 points more times than not. That was the value of the question. More people left that one blank than any other question on the test. Because they couldn't figure out what to do with phosphoric acid or what to do with the reaction.
I just misread it.
I had it right at first, but
Yeah, but at least you did the chart and just had the equation wrong. You did something. Some people just left it blank.
I did this part.
Anything else? Anything else?
This wall.
Yeah.
Oh, wait, no.
I don't even have a problem. No,
Maybe I
mean, I know what it is, but. I just 16 because I need to rock up.
There will never be a break. Never.
Anybody else? Question on this one before I switch? All right, hand me the stoichiometry test. That way I don't have a mix up of benchmarks.
Funny, I'm so glad you do the math, right?
Somebody let Lolly in before we forget him.
It happens.
All right. I take it nobody's letting Lolly in. We're just leaving her in the hallway. All right, now the benchmark. Yes, ma'am.
Okay, I have a question for number 2. So the answer that I got for number 2 was
0.90.
Yeah.
So which one was the, oh, never mind.
Okay,
Yeah,
well.
I think it was round
round
8 to 1.
7.
But then I was.
5.9 round to 1.
Because it's closer to 1 than
0.87 rounds to what?
Yeah, but that's a weird.
But you don't round down, you round up.
0.87 rounds up to 0.9.
But
It doesn't round down.
I got
To be fair, she's trying to tell us that.
Okay, well,
You people can't round.
Why would I say
Yes, you
that?
can. You can round.
0.9 does not round to 1.
It's 18. I had the same problem, but then I plugged in the answers. It's an
You don't even have time for that. I don't know if you can try the answers. I don't get the answer I got.
I got it right second time. I plugged in the answer. I did it like 3 times.
I believe you. The answer's still C.
This isn't even.
Oh, yeah.
Oh, yeah, that was.
I can look at you.
Between A and C, the better answer is C. 0.87 rounds to 0.9. The answer's 0.9.
That was the question I was thinking.
I was like, oh, 9 doesn't. I'm trying. This still doesn't have a 1.87. How would you do that? Like, I got 0.9. How would you do
I know what the answer is, people. I'm calculating it myself.
Why is it?
It's a question of the New York State test.
Well, you're already like 10 minutes.
Huh? Okay, I'll email New York State test.
Thank you.
Serious regard. It's like what? It's actually 0.998 grams per milliliter. 25%.
Okay,
It says one.
That's
so
so
why?
I'm still not changing the answer.
I got a round.
how do you get?
How you get it?
187 from 998.
If that's how you round, then I'm totally screwed.
I don't care.
Who's gonna round down to 80?
All right, are there other questions other than y'all arguing about that one?
Number 4.
Why can't
Number
you
4.
change
Okay. So number 4
Oh, yeah.
says, oh, yeah, this is a good one. So what two particles make up the nucleus of an atom?
I get it now.
Okay, the protons and the neutrons.
I got the protons.
So the protons have a charge of 8, and the neutrons have a charge of what?
Nothing.
Nothing. So the protons have how many? 8. So only the 8 positives make up the charge, which is why it's 8.
I got that right.
That was major trick.
I remember.
What is it?
I put
Guess
16
what?
first.
I remember.
thought about it.
I did
What
good.
does it make sense?
I think you should let us go home and study the correct answers and come back tomorrow. and take
Oh yeah, I didn't know what was going on.
Actually,
We should have
that's-
We don't have time to test correct.
I can do them at home.
No. What? Next.
The only thing I don't get is 25.
Yeah.
But other than that, I'm good.
I mean, I can make,
Mine
I can
said
make one
27.
statement, but I totally disagree.
Next.
Mine said
27. All right, 27. Meters to centimeters cubed. You probably forgot to cube when you did your chart.
Oh my God. And I said it when I was doing it, I was like, okay, it's cute. So I got cute both numbers. And I didn't. Oh wow. I didn't.
I didn't see those.
What question?
I just put it in the
Please don't do that on the phone.
Oh yeah. Oh, I actually tried.
Yes.
Huh?
39.
And that's the only thing I messed up. I didn't. Oh, we got down. What?
Grams. We just took a test on 39. 32 grams of copper. Grams of copper. Moles of copper. Moles of copper. Moles of water. Moles of water. Grams of water. So water has a 2. Copper has a 1. 63.5, I think is what it is. 1 and 18.
I knew it.
All right. Answer it. Thank you.
Anybody else? Because we're past my 9 o'clock deadline. We're not going to finish what I need to finish.
Thank you.
I mean,
Look.
wait, I just have a question. Okay, so I have a question that was like, number 15 of you observed that sodium hydroxide was dissolved in water. The temperature of the water increased due to the dissolving of sodium
Yeah.
hydroxide. Okay, so endothermic, is that when he,
And no, it's cold. It feels cold to the touch. See how it says the temperature increase? That's how you know it's excess.
is that added?
I thought.
And no gets cold to the touch and heat is absorbed. So it's cold. If it told you the temperature went down, that would tell you it's endo. But because it told you the temperature went up, it's exo, heat is released.
You marked one of them wrong.
So I got them right, I just got it wrong.
Okay, which one did I mark wrong? Who's right? Which one? Okay, 22 answers, hey, what
Y'all
did you mark?
Wait, hold on.
I got it.
Yeah, real.
Oh.
Wrong answer on the answer
No, I
sheet.
forgot to change it, because I changed it. I forgot to change my answer sheet.
Oh.
I even checked. Oh my god.
Anybody else?
Number six.
Number two?
Six.
6 would be a nice step, they have to have the same atomic numbers.
I feel
Atomic numbers and bomb numbers.
I want to take this to a chemistry professor. Which one was this?
Anybody else?
You don't go again.
Why?
Go once,
Why was it so?
go twice,
Every time.
go, give me your test papers.
Like, you never asked us to approve.
Oh, and then I didn't understand this. How to read that? Like, I couldn't read it. What the heck? It's like, what? Each line is a number. There's like 15 lines underneath it. How does it go from 0 to 10? And then 10, 11, 12, 13, 14. Like, how does that work?
I'll send the lowest years regards again to New York State.
Tell them to shove it.
Oh, yeah, that's.
I was gonna ask,
I just have to go
I
down
just
to
guessed,
the
because I remember we have one guess number, like, okay, so.
It was me because I was like,
Yeah.
which have the right answer.
Like, how does it?
25%, I'll take it.
21?
Oh, you said.
It's not.
Yeah.
Okay, but there was no.
Contact.
They had 10 lines between 10 lines.
You and Deja, so far, are the only two who didn't follow directions. I don't know, thanks, I counted, put it down, 43.
I mean, it's not that bad. I mean, it's bad, but it's not as bad as it.
He said a what?
Add that number of points back in. What is it, 1 point something, 2? 2.3? Alright. Alright, find the notes.
Oh, we're supposed to, I don't.
What is it? No, we're gonna go over. Oh, and find your homework. We gotta go over the homework. Find your homework and. I know.
Why?
I'm not actually gonna pull up the answer.
I'm pretty sure it was.
Yeah, I'm not working on next grade.
Miss Wall, tell Jay to get your account in this paper as a test rate for the homework.
Say what?
Never mind.
Well, we really waste time with this.
Are you even taking them?
Today, no, I'm not, but I'm gonna tell you something else about it.
Can I get this?
Were you not here? today?
I know.
It was from the day before.
We got it on Monday.
You got it Monday.
Oh, it wasn't here Monday.
Now, I am not checking the homework, A. B, I don't plan to go over the homework because the questions were identical to the opening. So you should already have the answers. If you've not done the homework, it goes with tonight's homework because we will probably not finish enough to be able to do all those questions tonight. So I will assign a certain number tonight. So if I check homework tomorrow, 1 through 10 is part of tonight's homework. So if I check tomorrow and you don't have it done, yes, I'm going to take off because tomorrow's grades start the new quarter, okay? I don't want you to start with a crappy grade. The quizzes will already most likely start crappy grades. Yes, ma'am.
Okay, I know that you said like one.
Yes, you can. If there's a question you want to ask, go ahead.
Tim, how do we determine the type of EMR using the electromagnetic?
Oh, yeah, how do we determine the type of EMR? Anybody know?
Just looking at the wavelength.
Yeah, it goes to wavelengths, based on wavelength.
That's what I put, but I didn't know.
Yeah, that's correct.
And then what is,
I don't know what they'd say.
what is the color frequency of light in the 6?
Okay, what did you put for 6.7? What color did you put for 6.7?
Red.
Red, that's correct. And what's the frequency?
4.8 times 14.
And the unit?
Hertz.
Yes? Okay. All right, everybody okay with that? So those of us who did it got those numbers. All right, if we didn't do it, make sure we have it tomorrow in case I check. Because, you know, at the front end of the quarter, most teachers tend to grade more at the front end because you have no grades. Just making that statement up front. Now, quiz has been tabled for tomorrow. Everybody's got that, right?
Oh, we're gonna.
Yeah, you came in late, so you missed that. All right.
Please tell me next week's gonna be easier.
Yeah.
Yes.
Fake?
Yeah.
Okay. All right, I need to fix the people who came in late. Well, y'all write that down. All right, who came in late? Jada came in. And who else came in? Lolly came in. So now we're only missing Karina. All right, so we're going to talk about the photoelectric effect and neon lights today. We might get to board, but I'll be surprised. The rest of that stuff, I'm not going to have. All right, so the photoelectric effect. I talked a little bit about on Monday. I was going to say, when was it the last time we talked about this stuff? The photoelectric effect is really weird, but this is why we talked about light could behave as particles and waves on Monday. Because this is where we see the two examples of where this occurs. So the photoelectric effect refers to the emission of electrons from a metal when light shines on the metal. Now, all of today's notes are typed, largely because when this was added back into the curriculum somewhere around 6 years ago, this hadn't been taught in the curriculum for 20 years, and you know, I was afraid I'd forget to teach it, so I typed it all. So I'll be writing on the board along with the type notes. So hopefully it'll be easier for you to write because it's typed. It's not my chicken scratch handwriting. But it refers to the emission of electrons from a metal when light shines on the metal. So you think of any metal. You think of aluminum foil at home in the drawer, okay? And light shines on the metal, and an electron is going to be knocked loose and come out of the metal. Now, when you think of that, all right? All right? The mystery of the photoelectric effect involves the frequency of light striking the metal. Can any kind of light do this? I mean, the light in here, the fluorescent light bulbs, the light that you have at home in your bedroom. No. And that's what's under the rest of the blind. Can you literally take the plain old compact fluorescent, the daylight bulbs, the whatever kind of light bulbs you have in your house, the fluorescent bulbs we have in this classroom, yank out a sheet of aluminum foil, lay it on your desk, shine a light on it, and knock an electron out of the aluminum foil? No, that sounds ridiculous even to me, and I don't do this stuff. Okay? I find it a little on the boring side, to be perfectly honest with you. Well, I tend to agree. Okay? So, how does this work is where we're going with this today. All right? So, wave theory predicted light of any frequency would eject an electron. Okay? So, our current wave theory at that time, at the time that the photoelectric effect was defined, wave theory said Yes, these lights in here would eject an electron. Was there proof? Is there proof? Yes, they did prove this.
What?
They did.
But when this
I
like.
don't know. This is so far above my IQ or something.
Okay, wait. What?
So aren't these people
Like any kind of light?
They proved that any kind of light would not work.
Okay.
They proved that any kind of light would not work.
Aren't they like candle time people? What? Like
No,
when
no,
candles.
no. This was like in the 40s and 50s. No, this was not candle time people. No, this was not back. No.
Like, what is wrong with these people?
No. This was not that far back in history. No. No candle time people.
I can't.
All right, have I given everybody time to write? I got it. No. We're not that far back in time. No. No Isaac Newton times. No. We're in the 1900s here. We have electricity and all of those things. All right, have I given everybody enough time now? Anybody need more time? All right.
This is a lot.
We're only on slide 14 to 28.
I mean, like, it's a lot to take in.
Yeah, we're not all there yet, so it's just a lot. I admit it openly and up front, it's a lot.
Miss Wall,
Yes,
can you send Sayla Hooks to the office? She's signing out.
I will.
Thank you.
Welcome. All right. Now, the only light above a certain frequency will knock electrons loose from a metal. Okay? So, scientists have a problem. Wave theory predicts any light will eject an electron. Okay? Wave theory says any light will eject an electron. But scientists are finding that only certain frequencies will knock electrons loose from a metal. Okay? That's what they're finding. Only certain frequencies knock electrons loose from a metal. So, there's a problem. Wave theory says any light. Scientists are finding only certain frequencies will knock electrons loose. So, they need some other explanation. So, here comes German physicist Max Planck. Max Planck proposes that electromagnetic energy is not released continuously, but in small packets called quanta.
Quantum theory.
Yes, that would be the name of where quantum theory comes from. Say what?
So really.
You're like, oh snap, I just found out something new.
Yes, I have to give it names.
So if I really want to whatever I want it. Dude, I can name it Swirly Butthole.
What?
And everyone would have to call it Swirly Butthole.
You
You know how much power I would have? You
I
have
want
to
to know
call it
what you
Swirly Butthole.
discovered to call it that. Like, were you just mad that day?
Swirly Butthole. I mean, just saying.
I mean, yeah.
PG-13.
Yeah, but it doesn't matter.
And then you can call it
She
Swirly.
just goes for the laughs. And then she finds like a whole new solar system.
If I discover something, I can name it whatever I want.
Sure.
So I can name it Swirly Butthole. Everyone would have to call it Swirly Butthole.
Sure.
Just a teacher casually agrees with it.
Sure.
Say that like.
My son tells me we eat bubbles regularly, 3-4 times a week at my house. What he calls cauliflower. He says it smells like buttholes.
How does he know what
I ask him that regularly. Dude, I don't know how you know what this smells like. Well, excuse me, just start 13. I do.
Ross sits there and says, I want to eat asparagus. Like, what's wrong with you?
Asparagus is actually.
I mean,
I like
sure, you
asparagus.
just sit there and just like,
Yeah.
I'm craving some asparagus.
I don't crave any vegetable, but I have to eat them. Now, just because Lolly enjoys new words, yep. Just remember that a quantum is a swirling bubble.
Yay.
All right, a quantum
That might be the only.
is a minimum amount of energy that can be lost or gained by an atom. Because we're going to use this word quantum quite a bit. Or in Lolly's mind, she's going to just swap out. Yep.
Just write down this.
Okay.
Credit.
So, in Max Planck's mind, all right, instead of energy being a line, it's not going to be a line anymore, okay? It's going to be small bursts or packets of energy, okay? He's saying they're not released continuously like this, okay? Doesn't work that way, okay? But they're going to be, and when I drew the dots, I'm trying to show that they're small packets. So this is a quantum. Okay, quanta is plural, quantum is singular. All right, so that is a quantum of energy. It is a small packet. This is a quantum of energy. This is a quantum of energy. All right, it's just an amount of energy that can be lost or gained by an atom. Are you with me? Kind of. It's okay. We're going to go through it once, then we'll come back through it. Say what?
One of the single dots.
Those are quantums. All of them together are a quanta. Quantum is singular. Quanta is plural. That's the only difference. Quantum is singular. Quanta is plural.
Isn't that already useful? Like this specific thing? None of that.
We've had this conversation.
I mean, I thought
We
maybe
don't
like,
need it.
We just need.
I never did to figure out like how to convert like as well. I don't care that much, but I thought maybe like this would be useful.
I
But I'm trying to find the light.
The process of converting might be useful. I've used that for other people in other areas of my life, but this content itself.
Would it be useful for forensics?
For what?
Forensics.
This right now, no. Other things we've done in here, yes. Okay? What this is going to lead to, like tomorrow's lesson, yes. This stuff, I have no idea why they put this back in the curriculum. I thought it was dumb that they put it back in the curriculum.
They said, hey, let's teach them more useful stuff.
And I don't know why they put this back in the curriculum. All right. This would not have been something I'd have added back in. So, moving on. A minimum quantum of energy is required to eject an electron. Okay? So remember, we're trying to eject an electron from a what? From a metal. So in order to eject an electron, scientists have figured out that you can't eject any amount. This light is not going to work. Wave theory says that these lights will eject an electron, right? Scientists are figuring out it has to have a certain frequency, okay? That certain frequency requires now a what? A minimum amount of energy, which is called a what? Which is called a quantum, okay? It requires a minimum quantum of energy to eject an electron. Now, Planck also said, it's not that bad. Planck also said there has to be a relationship between energy and frequency. Now, this has a formula. We're not calculating with the formula. Okay, we're only doing one math equation. We did it Monday. Now, the formula is E equals H nu. What do we know the standard E stands for in science class? Energy. E is energy. H is Planck's constant. And V we've learned. V is what? Frequency. Now, I put H up there to tell you it's Planck's constant, and I gave you the number just to illustrate it. You are never, ever going to have to know Planck's constant. I don't care if you write it down. Okay? I'm just telling you the formula. Never. Okay? I don't care if you write it down. Now, you do have to know the relationship. To illustrate something for you. When we did, I'm going to put the pen, that's in my pocket. When we did C equals lambda nu, they were on the same side of the formula, weren't they? What was the relationship? It's in the opening. That's right. They were opposites. They were inversely proportional, right? This time, energy and frequency are on opposite sides. One's on the left, one's on the right side of the equal sign, right? So what do you think the relationship is between energy and frequency this time? Okay, we don't use non, and they are proportional. I think I have it over here for us to write it down. Yep. All right. Does everybody have what they want here? All right. No.
What is that?
Yeah, it's called lambda. Oh yeah, Jada wasn't here.
Is the next question how frequency and energy are related?
Yep, how frequency and energy are related. I was just waiting. Owen told me he wasn't ready. All right, can I turn? All right. So how are they related? We don't use non-inversely, and we have to put a word in front of proportional. All right? They are directly proportional. All right, so what does it mean to say directly proportional? Yes. All right. One increases, the other increases. Okay, that's what it means. So, when we say an electron has to have a minimum amount of energy, it also has to have a minimum what? If we say the electron has to have a minimum energy, it also has to have a minimum what? Frequency. It also has to have a minimum frequency. Okay? You can't have one without having the other.
So you have to have both for the electron issue out?
Mm-hmm. Yep. I can't wait to tell Lolly the new word. Can't wait to see what she has to say about this one. Almost. All right. Here's your other scientists. All right. So Albert Einstein explained the photoelectric effect by proposing that light can be viewed as a stream of particles. Okay. So remember, I drew the quantum as little dots, right? So Albert Einstein is proposing that light can be viewed as a stream of particles. Instead of a wave, he's saying that it can be viewed as a stream of particles. All right, so if we're saying that this is a quantum, and that's a quantum, and that's a quantum, then it would be a stream of particles. Now, this is basically what I said a moment ago. Albert Einstein also says that each of these, down here, all right, that each of these particles, okay, carries a quantum of energy. Okay? So, let's see if I made my arrow look a little better. Now, so that would be a stream of light. And each of those particles is carrying a quantum of energy. Now, that quantum of energy is the minimum quantity that can be lost or gained. Now, that minimum energy also has to have a minimum frequency in order to be lost or gained.
When you say lost or gained, are you talking about the electrons or the energy?
Both.
Then I don't get that.
Because in order for the electron to be ejected, you have to have that minimum energy for the electron to be ejected.
But how do you lose energy? Don't you just lose electrons?
It goes to, I'm trying to use the language that I'm going to use when I get here. Because when we get there, we're going to talk about Bohr's theory, and electrons can move from a first energy level to a second energy level. And so they're going to go from up there to down here. And so they're going to absorb or release energy. I know it looks a little weird now. It makes a little more sense when we get there. No. I don't have anything that I can give you that makes sense. You're going to use neon lights in a few minutes, which makes a little more sense for most of you, because you can relate to those. You see those. The photoelectric effect is just so bizarre because there's nothing we use that has the photoelectric effect. Neon lights y'all use. You're familiar with those. That you can relate to. I even have one I'm going to set on the desk. But nobody uses the photoelectric effect. This is why I hate that they put it back in the curriculum. You just can't relate to it. It doesn't make sense to anybody. Nobody uses this crap. All right? What would you use it for? Absolutely nothing. All right. We're going to take this part out. All right. The grammar is not going to be right here, but we're going to take this part out because we don't need that.
Wow, a new word.
I know. I knew you'd love this part. All right. Just for Lolly. All right. Einstein named the particle something else. You know, because we don't have enough new vocabulary for Lolly today. All right. Instead of just calling the particles a quantum, he wanted to give them its own name. So when he said the particles in light, to view them as a stream of particles, all right, we said that they carry a quantum of energy, right?
Is that always the least amount?
Yep, it's got to be the minimum amount. They can have more than the minimum, but they got to have a minimum amount. He's giving them a name. All right? Einstein came along, and he wanted to give them a name. Now, they have a name. They're called a what? It's called a photon.
So they're not a
They are. But now the photon is a particle. It's a particle that does what? It carries a quantum of energy.
What?
Okay?
I thought it was a quantum.
It is. It's a particle that has a quantum of energy.
So quantum is not what it is, it describes it.
The photon is the particle that carries the quantum of energy. So all of these things are now what? They're all photons. And they all carry what? That is correct.
Why didn't we just skip all?
Oh my God.
I told you I was going to love this topic.
I think
Those are journal.
no.
I mean,
The stuff you missed is the easy part. Okay? Everybody got it? I didn't ask if you got it mentally.
Mentally.
All right, now. Whoops. So, the energy of the photon, or the energy of the particle, depends on the what? What does energy depend on?
Frequency.
Frequency. So the higher
Frequency.
that's right. The higher the energy, the higher the frequency. Why would energy depend on frequency?
Because they're best friends.
Directly proportional.
They're directly proportional.
Oh.
We just talked about this.
They're best
Wait.
friends.
If we go back right here, how are energy and frequency related?
They're directly.
They're directly proportional. So, the energy of a photon depends on frequency. Okay? So if I increase frequency, energy does what? It increases.
Let me guess, it makes more electrons come out too, right?
It would.
There's all radiation bad.
Okay? The higher the frequency, the higher the energy. Now, let me ask this. Do all metals on the periodic table, will all their electrons come out with the same frequency?
No.
No. Different metals require different frequencies.
So if the mass is higher frequency.
Not necessarily. That's way beyond what I know.
See, that one just makes too much sense.
People who are mute, how do you think they cough? Do they make sounds like that?
What?
Like, because mute people can't cough. Like,
Sign
do they
language.
just make sounds at all?
Like, do they, when they cough, do like sign language, so like a cough? Like,
They probably, I mean, they can make noise, they just don't know what it means.
Like, whenever you cough and you have to cough, in order to get something out of it.
She reminds me of my son in the worst way.
Yeah, like that's how, why can't they talk? Like,
They don't.
Because they're really deaf.
Actually heard
They're
it.
not, no, not all mute people.
What happens when they try to talk? Nothing comes out. Or like sound.
Usually it sounds.
But
Because I don't know what words that sound like, so it's usually just sounds.
Yeah.
To say nothing.
Don't they just say like sounds that
It's
sound
just
different?
grunting and sounds. They don't know what words sound like. They've never heard them.
Why?
Because that's something all people do.
tell them to stop.
What?
All right. This is the last slide before we go back and review. All right. So
So much radiation.
now this is basically a summary of what we've just done. Okay? This is basically a summary. So, in order for an electron to be ejected, okay? In order for an electron to be ejected from a metal, the electron in the metal must be struck by a what?
Photon.
A photon.
That's true.
Okay? Has to be struck by a photon. And the photon must have a what?
Quantum.
Or, that is correct, you can say quantum, which is just a minimum energy to knock it loose.
Wait. So
Okay?
That's sort of makes sense.
I mean, it makes.
aren't the same.
Okay? That minimum energy is called, here, let me change the color. So it's a little brighter. That minimum energy has a name. It's called a quantum. Okay? In order for an electron to be ejected from a metal, it must be struck by a single photon possessing a minimum energy required to knock it loose. A photon is just a particle. The photon is the particle. The quantum is the energy. Okay?
Okay, the minimum energy is
The minimum energy is the definition for the quantum. The quantum has to have the minimum energy. Yes, ma'am.
Okay, you said a single
okay.
photon.
Okay.
Is it just like at least a single one or only one?
Say it again.
Okay, so like, how do I word this? Okay, so you said must be struck by a single photon, but like, is it possible for it to be struck by multiple ones?
Yes. Yes.
Okay, so it's like at least.
Yes. Has to be struck by at least one, but it could be struck by more. Yes.
So is the relationship like we're humans and we like breathe oxygen, but we're not oxygen? It's like we use oxygen and that's what we have, but like we're not oxygen ourselves.
What?
Is that the same thing?
What is this? Physiology?
No, like photon,
No.
it's not, it is a photon, but it's not a quantum, it just has one.
Alright.
Photons are particles.
Yeah, that's like what it is.
Yes. And they have to have a minimum amount of energy.
Do you have me thinking that it was called?
This is so confusing.
It has to have a minimum amount of energy. Okay? So, if we think about this logically, all right? So we have a metal. Okay, some metal. Okay? And we have these particles. Okay? These particles are called photons. And they have a quantum of energy. Okay? Does that help? I know it's not a good drawing. But each of these particles that I drew here, each of those things are photons. All right? Now, when they hit, an electron will be ejected. Now, they'll only be ejected if they have enough energy and they have a high enough frequency. If they have a low frequency, will they be ejected? No. Okay?
You said only if they what?
Have a quantum of energy. Now, that quantum of energy has to be high energy, which means high frequency.
So you're not talking about the electrons.
No, I'm talking about the photon, the energy of the photon. The electron itself has nothing to do with it. That will just be ejected if the energy is high enough. Now, different metals are bonded differently. So they're going to require more or less energy. So all the quantums will vary. So copper, aluminum, gold, they're not going to require the same quantum of energy. Okay? Your aluminum foil and your gold necklace are not going to require the same quantum of energy to knock an electron loose.
It's gonna be, you're supposed to know what's going on.
It's recording now.
I'm gonna have to rewind.
They heard
It's
me
fine.
talk about swimming.
Huh? Yes, swirly buttholes are recorded.
Charles, you're sure not. But so what's the difference between a quantum and a photon?
The photon is the particle. The particle carries a quantum of energy.
Okay.
Okay? The photon is the particle. The particle carries the quantum of energy.
So are there different types of photons, or is there one?
There's only one photon.
That just have different quantities?
They have different amounts of energy.
Okay.
Okay? The photon that has more energy would work with a different material than one with less energy. Okay?
But didn't you say there are different types of light?
Yes. Some types of light have greater quantums of energy.
But they all have the same photon.
They all have photons. So the light that has a higher energy could knock out an electron in a different metal than one that has a lower energy. So if you have lower energy, you have lower frequency, you can't knock out an electron that requires a higher energy or a higher frequency because you have less energy, less quantum. Okay, you got to have a high energy or a higher minimum quantum to knock out an electron that requires a higher one. A photon is not, well, it's a particle, but it has to have a high enough quantum to knock out an electron. But a photon itself is not a number, no. Yes?
Does a photon have to have that specific number to knock out a metal?
Well, it would have to, the quantum would have to have a number.
You can't have more than knock out that metal. So if you have like a bunch of metals, if you have a bunch of metals, and then you have.
It would, the quantum itself would be assigned a number, yes.
Is this gonna be on the quiz?
But can
No numbers will be on the quiz.
this will be on it? So
Yes.
basically, the quiz is just
This is gonna be
memorization, kind of.
Wait,
Yeah.
what is the claim?
So what we are learning today will be.
If I ask what the photoelectric effect is, you should be able to tell me.
Okay.
If I ask what's required to knock a metal loose or an electron out of a metal, you should be able to tell me. There's more than one answer for that. Then you will get the question wrong.
Well, can you tell me now so I know?
It's on the worksheet.
Listen.
All right. Now,
I've been exposed to enough radiation.
let's talk about a ground and excited state real quick. This is easy. This will lighten the load a little bit. These two are easy. No, but I would recommend it. Ground and excited states are easy. I'll demonstrate it tomorrow. All right? When you have neon lights, most of y'all have seen these. I'll break them out tomorrow and we'll look at ours. All right? Although mine are kind of ugly compared to nice ones. Ground state and excited state. All neon lights have both. Ground state, excited state. Ground state's when they're off. Excited state's when they're on. Ground state is the state of lowest energy. And the excited state is a state of higher energy. Now, notice I said energy because there are multiple levels of excited states, okay? Multiple levels of excited states. So we're going to look at tomorrow going from the ground state to the excited state. So the electron is going to go from the ground to the excited state. Now, what happens when it gets to the excited state? Does it stay there?
No.
Does it explode? All right. Where's it go when it gets there? It goes back down. So when it goes back down, it releases or emits light, which is why you see the neon light. Now, when it goes up, it absorbs energy. Okay? It absorbs energy to go up, and it releases or emits light when it comes back down. Now,
So there's only one state of. There's only one state.
the ground state's when it's off. The electrons are chilling. They're off. No, nothing's passing through. I'm going to talk about it tomorrow.
But there's only one of those.
Only one ground state. But the excited state, there's multiple levels. Okay? And I'm going to show you what happens when an electrical current passes through it tomorrow. All right? Now, on your worksheet, let's see what we can answer tonight. You've done 1 through 10. You should be able to answer through 17.
I didn't see that.
You can do through 17. And then you can do 23, 24, 25. 1 through 17, and then 23, 24, and 25. Okay? 1 through 17 and 23 through 25.
The level of stress.
The level of stress. It's terrible.